Hey everyone, this is Matlub Ahmad back with our third video, and today we're taking kinetic energy to the next level. We've talked about the basics, we've seen the formula, but now, let's dive into how kinetic energy is at play in nature and sports. Kinetic energy isn't just something you find in a physics textbook, it's everywhere. When you run, jump, swim, or even ride a bike, you're experiencing kinetic energy firsthand. Let's kick things off with something super relatable: sports. Think about your favorite sport. Whether it's soccer, basketball, baseball, or even skateboarding, kinetic energy is making everything happen. Basketball. When a player dribbles, the ball moves up and down. The higher the bounce, the more kinetic energy it has. And when a player jumps for a slam dunk, their kinetic energy increases with speed. Soccer. Ever noticed how a slow kick barely moves the ball, but a powerful strike sends it flying? That's kinetic energy in action. The faster the ball moves, the more kinetic energy it carries. Running and sprinting. A sprinter at the start of a race has low kinetic energy, but as they pick up speed, their kinetic energy increases. That's why world-class sprinters can cover 100 meters in under 10 seconds. They maximize their speed and kinetic energy. Tennis. When a player hits the ball, the racket transfers kinetic energy to it. The harder the hit, the more energy is transferred, making the ball travel faster. Cycling. When you pedal a bike, you're giving it kinetic energy. If you stop pedaling, friction and air resistance start taking energy away, eventually slowing you down. That's why cyclists lean forward, to reduce air resistance and keep more of their kinetic energy. Now let's step outside the sports world and look at nature. Ocean waves. Ever watched waves crashing on the shore? That's kinetic energy at work. The wind transfers energy to the water, making it move. The bigger the wave, the more kinetic energy it carries. Wind. Wind is just moving air, and moving air means kinetic energy. Wind turbines capture this energy and turn it into electricity. That's how wind power works. Animals in motion. Think of a cheetah, the fastest land animal. When it starts running, it rapidly builds up kinetic energy. The faster it moves, the more energy it has, and that's why it can reach speeds of over 70 miles per hour in seconds. Waterfalls and rivers. Water flowing in a river or falling down a waterfall has kinetic energy. The faster it moves, the more energy it has. That's why hydroelectric dams can generate power using moving water. Now here's a cool fact. The kinetic energy of an object depends on two things: its mass and its speed. If two objects move at the same speed, the heavier one has more kinetic energy. That's why a bowling ball hits harder than a tennis ball at the same speed. And remember the formula? KE = 1/2 mv2. That means if you double the speed, kinetic energy increases 4 times. So the faster something moves, the more energy it has. That's why a fast-moving soccer ball is harder to stop than a slow one. Let's say you're riding a skateboard and you slowly roll forward. Now imagine pushing off hard and zooming ahead. Which time do you have more kinetic energy? Yep, the faster one. More speed means more kinetic energy. Kinetic energy is everywhere, in sports, in nature, and in our daily lives. From running and jumping to ocean waves and wind turbines, this invisible force is constantly at work. Before you go, don't forget to like, subscribe, and hit the notification bell so you never miss a new lesson. Drop a comment below and tell us, what's your favorite real-life example of kinetic energy? Thanks for watching, and I'll see you in the next video.